The AI data architecture universe, where use cases meet data reality. The central truth, data types drive AI capabilities. At the heart of this circular diagram lies a fundamental truth that many AI projects ignore at their peril. The type of data you have determines what AI use cases are actually possible. This isn't just a technical consideration. It's the difference between AI projects that deliver real business value and those that become expensive experiments. The diagram reveals a sophisticated mapping between the outer ring of AI use cases and the inner rings of data types, showing how successful AI implementation requires understanding this relationship from the ground up. The outer ring, AI use cases in the wild. Customer intelligence, the behavioral goldmine. Customer segmentation and fraud detection dominates significant portions of the outer ring, reflecting their maturity and proven ROI in enterprise environments. These use cases have succeeded because they align perfectly with the types of data businesses naturally collect: transaction records, behavioral logs, and demographic information. Customer segmentation thrives on the intersection of structured transaction data and semi-structured behavioral logs, while fraud detection leverages the power of real-time transaction streams combined with historical pattern analysis. Operational excellence, the efficiency engine. Predictive maintenance, demand forecasting, and supply chain optimization represent the operational AI use cases that have moved beyond proof of concept to production deployment. These applications succeed because they work with well-structured time series data that industrial systems have been collecting for decades. The key insight here is that these use cases don't require exotic data types. They extract maximum value from sensor data, historical records, and operational logs that most organizations already possess. Content intelligence, the unstructured revolution. Document processing, content moderation, and sentiment analysis occupy substantial space in the diagram, reflecting the massive opportunity in unstructured data processing. What's particularly interesting is how these use cases bridge multiple data types. Document processing works with both text and metadata, while content moderation might combine image analysis with contextual text understanding. The data type layers from structure to chaos. The structured core, traditional database excellence. At the center, we see relational DBs, transactional data, and social media posts forming the structured foundation. This represents the comfort zone for most organizations: clean, queryable, well-understood data types that have powered business intelligence for decades. These structured data types enable use cases like customer segmentation, fraud detection, and basic recommendation systems. They provide the reliable foundation upon which more complex AI applications can be built. The semi-structured bridge, JSON and beyond. Moving outward, JSON LD, RDF, XML, and various JSON formats represent the semi-structured middle ground. This layer is crucial because it bridges the gap between traditional structured data and the messy reality of modern data ecosystems. Semi-structured data enables more sophisticated use cases like intent entity mapping, product recommendations, and complex document processing workflows. The flexibility of these formats allows AI systems to handle varying data schemas while maintaining some organizational structure. The unstructured frontier, where AI shines. The outer data layers showcase where modern AI truly differentiates itself. Telemetry data, sensor time series, email headers, log files, dialog state tables, and clickstream data. These represent the vast repositories of unstructured and semi-structured data that traditional analytics couldn't effectively process. This is where the real AI revolution is happening, transforming previously unusable data into actionable insights through natural language processing, computer vision, and advanced pattern recognition. The strategic alignment, use case data type harmonies, the perfect matches. The diagram reveals several sweet spots where use cases align perfectly with available data types. Fraud detection with transaction records, the classic pairing that launched AI in financial services. Real-time transaction data provides the perfect foundation for anomaly detection and pattern recognition. Predictive maintenance with sensor time series. Industrial IoT data streams enable sophisticated failure prediction models that can save millions in equipment downtime. Customer segmentation with CRM data plus purchase logs. The combination of structured customer data with behavioral logs creates rich segmentation possibilities. The complex orchestrations. Recommendation systems combine structured user profiles, semi-structured preference data, and unstructured behavioral logs to create personalized experiences. Supply chain optimization integrates structured inventory data, semi-structured supplier information, and unstructured market intelligence simultaneously. Content moderation processes structured metadata, semi-structured context information, and unstructured media content simultaneously. The implementation reality, data quality determines AI success. The garbage in, garbage out principle. This diagram makes clear that AI use case success isn't just about algorithm selection, it's fundamentally about data readiness. The most sophisticated machine learning model will fail if fed poor quality data, regardless of the use case's theoretical potential. Organizations often approach AI backwards, starting with exciting use cases and then trying to find data to support them. The diagram suggests a more pragmatic approach. Start with your best, most reliable data types and identify use cases that can deliver value with that foundation. The data pipeline prerequisites. Each data type in the diagram implies a different set of infrastructure requirements. Structured data requires traditional ETL pipelines, data warehousing, and SQL-based processing capabilities. Semi-structured data needs flexible ingestion systems, schema evolution management, and NoSQL processing capabilities. Unstructured data demands specialized processing pipelines, feature extraction systems, and often real-time streaming architectures. The evolution path, from simple to sophisticated. Starting simple, the structured foundation. Organizations beginning their AI journey should focus on use cases that leverage existing structured data assets. Customer segmentation with CRM data, basic fraud detection with transaction logs, and simple demand forecasting with historical sales data provide quick wins and learning opportunities. Building complexity, semi-structured integration. The next evolution involves incorporating semi-structured data sources, adding web analytics to customer segmentation models, incorporating supplier data into demand forecasting, or enhancing fraud detection with device fingerprinting data. Advanced applications, unstructured mastery. The most sophisticated applications combine all data types. Advanced recommendation systems that incorporate product images, customer reviews, browsing behavior, and social media sentiment represent the cutting edge of AI implementation. The strategic implications, data-driven AI strategy, inventory before innovation. This diagram suggests that effective AI strategy starts with a comprehensive data inventory. Understanding what data types you have, their quality levels, and their accessibility determines which use cases are realistic in the short term versus long-term aspirations. Infrastructure investment priorities. The data types you want to leverage determine your infrastructure investment priorities. Organizations focused on unstructured data need different capabilities than those optimizing structured data processing. Talent and skills alignment. Different data types require different skill sets. Structured data analysis leverages traditional data science skills, while unstructured data processing requires expertise in NLP, computer vision, and specialized deep learning techniques. The future landscape, convergence and integration. The unified data platform vision. The most successful AI implementations of the future will seamlessly integrate all data types shown in this diagram. Modern data platforms are evolving to handle structured, semi-structured, and unstructured data within unified architectures. Real-time integration challenges. The diagram hints at one of AI's biggest challenges, integrating real-time streams with historical data across multiple data types. Future AI systems will need to make decisions based on live sensor data, historical patterns, and contextual information simultaneously. The democratization opportunity. As tools for handling diverse data types become more accessible, the use cases shown in this diagram will become available to smaller organizations. The current enterprise-only applications will democratize across industries and company sizes. The bottom line, data architecture is AI strategy. This diagram delivers a crucial message. AI strategy is fundamentally data architecture strategy. The use cases you can successfully implement are constrained by the data types you can effectively collect, store, process, and analyze. Organizations that understand this relationship, that start with their data reality and build toward AI ambitions, will see far better results than those that chase exciting use cases without considering the data foundation required to support them. The most successful AI implementations don't just happen, they're architected from the data up, with clear understanding of how different data types enable different categories of intelligent applications. In the world of AI, your data architecture is your destiny.